Let's talk a little bit about movement of the arm. Now, when we look at the scapula, and we talk about taking this arm, which is at your side, and we want to take it all the way to 180 degrees, all that movement is not coming through the glenohumeral joint. Part of it is coming through the scapula. So we use the word scapulohumeral rhythm. So it's important to understand how this is all working. Because again, if the force couples are off, the timing of how muscles are contracting, maybe a muscle's overactive, a muscle's underactive, then you disrupt the entire mechanics of what it takes to get an arm from here all the way to that overhead position. So, from an earlier video I talked about how we initiate movement, not necessarily through the deltoid, because the deltoid has a vertical pull. So if we just initiated movement with the deltoid would just simply pull straight up, and the humeral head would butt itself right up under this chromium process. So the first thing that has to happen is we have to change the position of the line of pull of the deltoid. So generally about the first 10 to 15 degrees is not much deltoid activity, a lot more rotator cuff activity, because the supraspinatus has a different line of pull than the deltoid. And it does two things. It starts to change the angle position because it has an upward, but it also has an inward pull, and it's trying to draw this head tighter into the cup, if you want to call it, the glenoid fossa, so we have a more congruent surface, because this is a highly unstable joint. But we can't just have the supraspinatus pulling, we have to have the other three rotator cuffs, the lower ones that are pulling, so the infraspinatus, the subscap, and the teres minor, that are going to oppose the upward and inward pull of the supraspinatus by having a downward and inward pull. But nonetheless, the head gets drawn in, and it starts to rotate on itself until we get to about this first 10 to 15 degrees. Now, we're giving great opportunity for the deltoid to activate its pulling. So now what starts to happen is the deltoid starts to pull. But while the deltoid is pulling, the scapula is also upward rotating. So we've got a lot of muscles involved now that are going to create that upward rotation. And so we talk about a 2-to-1 ratio, where for every 2 degrees of humeral movement, there's 1 degree of scapular movement. And so we're going to have what? For every 2 degrees here, 1 degree there. And that'll continue until you get to about 120 degrees. So call it, that being 9 o'clock, let's call it the 10 o'clock position. At that point, that 2-to-1 ratio changes. Now it becomes more of a 1-to-1 ratio, which means for every degree of movement here, you're getting a degree of movement here. And that's because the deltoid is reaching the point where it's starting to shorten, and it doesn't have much more shortening to undergo. So now from about this position to about that position, call it the 11 o'clock position, so getting into the 150 degree range, now you've got about a 1-to-1 scapulohumeral rhythm. And then when you get to about that 11 o'clock position, there's not much more movement of the humeral head. The humeral head's pretty much rotated as much as it can. Now the remaining movement that gets you from here to here is going to be a little bit more scapular movement. This is where you can kind of feel your scapula really push up. As we went up, it didn't just upward rotate, it also had to tilt itself backward while it was rotating itself to position that head in the optimal position, because we want to play up here. So your scapula actually undergoes movement in 3 planes as we go overhead. It undergoes this upward rotation, it does a little bit of tilting, and it also has to change the position of the glenoid fossa to rotate it to position it in the optimal position for us to operate overhead. And that last, call it 20 to 30 degrees, is really going to be the scapula moving. Could be a little bit of your pecs and your lats pulling in, a little bit of your traps pulling in to get us to the overhead position.